question 2 was about the integers mod 24 and finding which of the integers were units and which ones were zero divisors. Now the key to remember is that in the integers mod n, you're a unit if the highest common factor of u and n is 1, and if the highest common factor isn't 1, then you're a zero divisor. Now, one thing I want to remind you is that 0 is a zero divisor. 0 is a zero divisor in the integers mod n. 0 is always a zero divisor unless you're in the 0 ring where there is only 0. Because what does it mean to be a zero divisor? It means that there exists, so A is a zero divisor if there exists some B in the ring such that B is non-zero and AB is equal to 0. So for 0 itself, you can always find a non-zero B such that AB equals 0, because AB is always 0. Right? You can always find a non-zero B as long as there is some non-zero B in the ring, and if the only thing in the ring is 0, then you're not going to be able to find it. Okay, enough about that. So most people, in fact everyone whose work I saw, was able to find what the inverses of the units were. So remember, a unit is A such that there exists B with AB equals 1. Now, these two things look a bit similar. You're a zero divisor if you can find B such that AB equals 0. And you're a unit if you can find B such that AB equals 1. Now, in this case, B here is called the inverse. But be careful, because in this case here, B is not called the inverse. And some people called it an inverse. It's not an inverse. I know it feels something a bit like an inverse because it's the B where B is doing something useful, but it's not an inverse, so be careful about that. It doesn't really have a name, not that I know. Anyway, it's just some B such that AB equals 0. Now, when you're finding B such that AB equals 0, let's just think about this for a second. It's fairly obvious in Z mod 24. For example, 2 is a zero divisor, and it's pretty obvious that 2 times 12 is 24, and 24 is the same as 0 in Z mod 24. So it's quite obvious that 2 times 12 is 24, which is congruent to 0. Likewise, 3, so all the factors of 24, it's pretty easy, because you just find the thing that multiplies it to 24. 4 sixes are 24, 6 as well, you get 6 4s are 24, 8, that's another factor, is easy, 8 3s are 24. So all these, it's quite obvious how you find another number, such that when you multiply it you get 24, which is 0. 12. 12 times 2 is 24. The ones for which it's less obvious are the numbers which have factors with 24 but aren't actually factors with 24. So, for example, what's the first one we're going to get? Well, for example, 14. 14, so the highest common factor of 14 and 24 is clearly not 1. So what is 14? 14 is 2 times 7, and 24 is 2, well it's 3 times 8, right? So it's 2 times 2 times 2 times 3. So if you examine these two products of prime numbers, you can see that if you're trying to multiply, what we're trying to do is we're trying to multiply this by something so that we get something divisible by 24. So you can see what factors you need in order to be divisible by 24. For any number to be divisible by 24, you can factorize it into its prime factorization and then see whether you've got 3 2s and a 3. And if so, you're divisible by 24. Here, we've only got 1 2. So what are we missing? We're missing 2 2s and a 3. So if we throw in 2 2s and a 3, we're going to get a factor of 24. So it's now clear that 2 times 7 times 2 times 2 times 3 is going to be divisible by 24, right? And this part is 14, so all we have to do is work out what that part is, and that's 2 times 2 times 3, which is 12. So we know that 14, what is he saying, is that 14 times 12 is congruent to 0, mod 24. So let's just do another one of those to see if we've got the idea. Let's do 16. 16 equals 2 times 2 times 2 times 2, right? And again, 24 is 2 times 2 times 2 times 3. So what are we missing here? 16 is not divisible by 24 because we haven't got this 3. We've got enough 2's because we need 3 2's, but we haven't got this 3. So what we have to throw in here is a 3, right? So 16 times 3 is going to be 2 times 2 times 2 times 2 times 3, and that's certainly divisible by 24, right? So 16 times 3 is going to be congruent to 0 mod 24. Let's do one more to see if we've got the hang of this. Let's do 18. Okay, 18, well 18 is 2 times 9, so that's 2 times 3 times 3. 24, again, is 2 times 2 times 2 times 3. So what have we got here? We've got a 2, we've got a 3, but we're missing a couple more 2's. So we need to throw in a couple of 2's. So 18 times 2 times 2 is going to be divisible by 24. So 18 times 4 is going to be congruent to 0, mod 24. And notice that I've done this without ever actually working out what 18 times 4 is. I don't know what 18 times 4 is. I could work it out, but I don't need to work it out in order to know it's divisible by 24. I can just look at its prime factorization, which is 2 times 3 times 3 for the 18 part, times 2 times 2. See, we've got 3 2's and 3, so it's divisible by 24. So hopefully, you've now got the hang of that.